So once again, good morning to all of you. This is your course instructor, Khushwant Fatnani. Let us start off with the session. So in today's session, we are continuing with the topic oscillations. So let us do one thing. Let us finish off with the assignment questions that we were doing. So we are in the chapter oscillations and waves. In fact, the unit oscillations and wave. So I'll be very grateful if one of you could take the charge and finish off with the topic. So Atul, can you please read the next question which was in the pipeline and until where we had finished? Yes, Atul. So I think if I've muted, just give me some time. Yes. So now you all are free to speak. Yes, go ahead. So kindly open your assignment number 11 where we were. Let us continue with the same. Yes.
So sixth question, sir.
Sixth question. So I think we had found out in the last question the value of displacement, etc. But we haven't
Yes, sir.
drawn the force time graph, right? Force time graph.
And well, yes, sir.
So in question number 5, let us see how will the force time graph be. So force time graph, right? So we had got this, right? That if x is equal to a sine omega t, we get v is equal to a omega cos omega t, right? Therefore, acceleration is minus a omega square sine omega t. Therefore, force is mass into acceleration or minus a m omega square sine omega t, right? So this force variation with time and force variation with x, we have found that v is equal to a under root of, sorry, omega under root of a square minus x square. We also found that acceleration a equal to, yes, how is it given in terms of x?
Uh, Acceleration.
Yes,
Acceleration.
just see the notes.
Minus a omega square x minus omega square
Right.
x.
Omega square x. Absolutely correct. Absolutely correct. Excellent. So we have this, and then how do we write force in terms of x?
Minus kx.
Minus kx. Very good. So now suppose I ask you to plot the graph between all of these variables, right? So one by one, let's see the graph. So let's say we'll plot 4 graphs here, right? 1, 2, 3, and here 4. Or we'll just draw it on a case to case basis. Let's say the first one. Tell me, Atul, what kind of graph this should be? This should be a sine graph, right? X and t, correct?
Yes, sir.
Okay, so let's draw
Yes,
it.
sir.
Class will request you all to please keep these graphs with you because they are going to be very handy whenever you have any questions based upon them, right? So we have first xt graph. It is very evident that the xt graph is going to be a sine graph, a sine graph. Okay. How about next one?
Velocity time graph will be cos graph.
Cos graph. Okay. So yesterday Atul had told that in order to draw a cos graph, we need to see that the graph should start from a maximum value, a very starking difference between sine and cos. The rest remains same. The rest will remain same, but then it should start from here x max, whereas a sine graph will start from 0. Here,
zero.
this is how we differentiate between a sine graph and a cos graph, right? So this was a cos graph between velocity and time. So we got a graph between x and time. We got a graph between velocity and time, right? So let's mark it with another color. So this is x, this is t, this is v, this is t. How will the graph between acceleration and time look like?
Sine graph only.
Okay. Are you sure?
Mm, yes, sir.
Should it be a positive sine graph or a negative?
Negative sine graph. Negative.
Class, have a look here. The graph between acceleration and time. The graph between acceleration and time is a negative sine graph. So all you need to do is just inverse or reverse this sine graph about the x-axis. So this is how your graph will look like. See here, class. This is how your graph will look like. So that is, we have reversed the graph about the x-axis. Why? Because here we have sine negative of sine omega t. So this is graph between acceleration and time. Also, please note that in graphs you may be given maximum values. So see here, this is the maximum value of x. This is a omega is the maximum value of velocity. A omega square is the maximum value of acceleration. M a omega square is the maximum value of force. Please note this, class. These are the maximum values. Note it, class. Note it in the notebooks. These are the maximum values, right? So from here in the graph, I can mark, where will I mark x max or v max? See here, this will be a, this will be minus a. Similarly, this v is oscillating between a omega and minus a omega. Similarly, here acceleration is oscillating between minus a omega square and a omega square, right? So this is how acceleration varies with time. Now let us draw variation of force with time. Okay, so Atul, how do you think the variation of force with time look like?
Negative sine graph.
Let us check. So it is also a negative sine graph, absolutely correct. And what are the maximum and minimum values of force?
Am omega square.
Yes, am omega square or ma omega square. So we'll write the same here. Let us write. So this value and this value are going to be ma omega square and minus ma omega square, right? These values. Between this, the force is varying with time and it is a negative sine graph. Remember, why have I drawn it from here? It's a negative sine graph, minus sine, and therefore in this manner. All right, class, is this concept clear to all of you? How we are drawing the graph between variables? If yes, please raise your hand. Yes, class. Okay, Atul, is it clear to you?
Yes, sir.
Entire
Yes, sir.
concept,
Yes, sir.
drawing graphs. Okay, super, super. So yeah, Atul, now, okay, now let us take one another of you. Let's take Karuna. Thank you, Atul. Thank you. So
Thank you.
let us take Karuna. Karuna, can you please try guessing how will you plot a graph between how will you plot a graph between v square and x square and v and x both one by one? Tell me. Any trials? Yes.
So for v
Karuna,
square,
your voice is very like is not audible. Can you please come closer to the microphone? And
yes,
yes, Karuna. Thank you.
for v square and x square, so will it be
Should
a straight line?
what should we do? Should we try to maybe let us try to write this equation, right? Because for
Yeah,
everyone to understand, we should try elaborating it. Okay, so we'll have b square is equal to omega square times
only
a square minus x square, right? Can we write it
yes, sir.
on by
Yeah,
squaring both sides?
yes, sir.
All right, now let us take v square to be another variable capital Y, right? Then we'll have omega square a square minus omega square x square. So let us take this omega square a square as some constant. Tell me, is omega a constant or is it a variable?
It's a variable, constant, sir.
Constant. It's not varying with time. For a given SHM, we generally take amplitude A and omega to be constants. They are constant values, right? So let us take them as k naught, right? Or let us take them as k naught and this as k, right? And this x square, let me take it as capital X. So now when I plot a graph between v square, that is y, and x, what is x? X is small x square, and this one is v square. What will be the graph looking like? Just have a look at this graph. Tell me, Karuna, what is this graph looking like?
Straight line graph, sir.
Absolutely correct. So is it a falling line or is it a rising line? Its slope is negative or positive?
Uh, Negative slope, sir.
Very good. So we'll have a graph of, and what about the c value, that is y-intercept? Is it positive or negative?
Positive k naught.
Very good. So should we have a line of this sort, Karuna,
Yes, sir.
where this y-intercept or y-intercept is positive and given by omega square a square, right? And its slope, right? Its slope is given as minus
Minus k.
omega square, right?
Yeah.
Are we correct on this, Karuna?
Yes, sir.
Okay. Class, I hope this is clear to each one of you, right? How am I drawing a graph between v square and x square? Now, how about the graph between v square, v and x, Karuna? Can we also draw a graph between v and x? Yes. Try guessing. So class, these are very simple and minute basics, but I really understand that such kind of basics are very important when you're solving questions with this chapter. So we are particularly giving good attention to this one, right? All right. Yes. Yes, Karuna. Tell me.
So we can write the equation as v is equal to omega.
We can write the equation v is equal to omega under root of a square minus x square. What is our aim? Our aim is to plot a graph between v and x.
And
So now uh, let's think. Let's say we'll write this as v square, right, is equal to omega square a square minus x square, right? Now
yes, sir.
you can write b square is equal to omega square a square minus omega square x square. Therefore, we have b square plus x square omega square is equal to omega square a square. Correct? So we have
Yes, sir.
b upon a omega, right, square plus x upon a square. Can we write it this way?
Yes, sir.
Have you heard of
Uh,
an equation of this sort? Try recalling our basics from the chapter. Our,
so x by
just think about it. Don't be very quick answering. Maybe you can think a little. See, we had learned this kind of equation. Y square, right, plus x square. Y square by b square, x square by a square is equal to 1. This is the equation of n. This is the equation of,
ellipse. Ellipse.
Yes. Try recalling. Have we read this? Right?
Yes, sir.
So we have an ellipse given by, class, have a look. This is the equation of an ellipse. Let's say between y and x, right? An equation of an ellipse is of this sort, or maybe I'll draw it here, right? This is how the equation of ellipse given as, it is written as x by a, or x square by a square plus y square by b square is equal to 1. So this is called as semi-major axis or A, and this is called as semi-minor axis or B. Am I correct, Karuna? Right?
Yes, sir.
So
Yeah.
try comparing the equation which we have just got, that is v square upon a square omega square plus x square upon a square is equal to 1. Does this equation resonate with the one which we have taken here, Karuna? Are the two
Yes.
equations of the similar sort?
Yes, sir.
Right? Now have a look, class. If we are therefore drawing a graph between velocity and displacement, the graph is going to look something like ellipse graph, right? So we will write this. On the x-axis, let us plot x. On the y-axis, let us plot v. So the graph is going to look like this, right? Am I correct, Karuna?
Yes, sir.
Right? So we have a graph between velocity and displacement is going to look like a parabola, is going to look like an ellipse, and this graph is going to have its maximum values for v as a omega and minus a omega, right? And the values for x are going to be a
Yes.
and minus a respectively, right? Can we see this,
Yes.
everyone, right? And also we know that v max is given as a omega and x max is given as a, right? So see, class, this is what we already know, and we can also see this in the graph, right? See, if I talk about x, see how x is varying. X is varying between minus a, right? Minus a and a, right? Between this entire portion, we have variation of displacement taking place. This x value is not going beyond a. So what can I conclude? I can conclude that x max is nothing but a or amplitude. Similarly here, just have a look. If you go along the graph, the velocity is just varying between minus a omega and a omega. It is not going beyond a omega or beyond minus a omega, right? It's just varying between these two terms, and therefore we have the maximum value of velocity is a omega. Class, is this point clear to everyone? And class, have you been able to digest what I have just told? If yes, please raise your hand. If this two graph, class, graph between v square and x square and graph between v and x, if these two graphs are clear to you, please raise your hand. Yes, class. And be very frank in asking any query you have. Yes. Because if you say yes, I might ask any question further, right? So please be very truthful when you're saying that you have understood a concept. Yes, class.
Sir, in this case, the x-axis is the major axis.
The x-axis is the major axis. Yes.
I think so. Should be the major axis.
Yes. So yeah. So you're true. It's true. So we have this as a, right? This one is also a. This is a omega. This is a omega, right?
No, sir, I was thinking that we can plot v on the x-axis and x on the y-axis.
So the thing is, it's up to us where we want to take which variable. So if you want to plot,
Okay, okay, okay.
so
Uh,
yeah, you are right. If you wish, you can take v on x-axis. You can take x on y-axis. It's up to you. So here, my way of writing the graph. So okay. So if that's the case, we can just write this equation the other way. So we can write y square by b square plus x square by a square. Now check this. Does it seem okay now, Atul?
Yes, sir.
Right?
Yes, sir.
Just about how I arrange the terms. So I had written it the other way, but then you can always exchange them and then accordingly plot your graph. So if along with y b is coming, right? If along with y b is coming, then b will be semi-major axis, right? Similarly here, see here along with v, a omega is coming. So a omega will be the semi-minor axis, right? Is the doubt cleared by the way,
Okay.
Atul?
Yes, sir. Yes, sir.
Okay, okay, great, great. So I think all of you have raised hands, so we are clear with both the concepts. So, so now we have plotted a graph between all of this: x and t, v and t, a and t, f and t, v and x. How about a and x? Karuna, tell me. How about the graph between a and x? First of all, I would request you to tell to the class what is the equation between a and x. Yes.
So it's minus
Minus omega square x, right? Now let us plot
yeah.
the, okay. So we have vertical axis, we have horizontal axis. Now, yes, tell me, what kind of graph should we draw?
Uh, Sir, it's a parabola.
Think again. Between a and omega or a and x?
Oh,
Instead of a, take y, right? Instead of x, take x. And instead of omega square, take k. Now tell me. Yes, now tell me.
so straight line.
Hmm. So parabola graph is possible, but then that graph would be between a and omega, right? A and omega. What is the graph that we are looking forward to? It's between a and x. Are you
X.
able to connect this, Karuna?
Yes, sir.
Sure.
Yeah, yes, sir.
Tell where were you mistaken and now why are we correct? Yes.
So because we have to plot a and x graph, not
Ah,
a and omega.
we have to plot a and x graph. Super, super. So we'll have will okay. Tell me which of the following is the correct graph: red or green line?
Red,
Why? Why is red the right line?
because it's a negative slope.
Because here in the graph class, just have a look. In this graph, the slope is negative, right? So we'll take a falling line. Try recalling our lectures. It is a falling line, right? So here the slope is negative, the slope is negative and equal to minus k, right? So our graph will be, or minus k, instead of minus k, I can write minus omega square, right? Minus omega square. So this is how we'll plot a graph between acceleration and time. So our purpose was plot graph for acceleration versus displacement, pardon me, acceleration versus displacement. Are we clear with this, Karuna?
Yes, sir.
Okay, now how about the graph between force and displacement?
Straight line. It's
Sure?
yes, sir.
Okay. So we will have this as minus omega square. So class, whenever you're drawing such graphs, no, whichever variable is on the LHS, it into y. This is the approach. Convert the variable on the right with into x and then try to think y is equal to minus kx. Okay, this is an equation of a straight line, right? So you'll write y here and x here, right? So this is how the graph is going to look like. Correct? Am I correct here, Karuna?
Yes, sir.
Okay, great. All right. So now let us go for the next question. Can you read the last sixth question, Karuna? I think sixth or seventh, whichever was the last. Yes.
Sixth. So x is given as 4 into cos pi 2 plus sine pi 2.
Okay, so the question in the assignment is given as x is equal to 4 cos pi t plus 4 sine pi t. First of all, okay, and what is the question asking us? To find the amplitude. To
Amplitude.
find the amplitude, right? Now tell me one thing. Can we actually find the amplitude in this case? Or is it, first of all, is it SHM or not? Let us discuss this. Is this SHM?
No, sir.
Try thinking. Class, anybody else? So we have Samriddhi, Atul, Anukriti, Mahila, and Karuna in the class. So would like you all to tell me that is it anyhow or anyways an SHM equation? What was the general equation for SHM, Karuna? What was the general equation of SHM?
So a sine
X is equal to
x is
A
equal to
sine
a sine
omega t
omega t
plus
plus,
phi, right?
yeah.
So now that we know this was the general equation, I will write this as maybe over here. If I know that this was the general equation and whereas the one which is given in the question are very different, okay, then now let's see how can we relate this. Think, think about it. Class, anyone, can we try converting this graph or this equation into this form? Yes, class. Just use your brains, try thinking. If not, I am there to correct, but first try to think. Yes. Okay, try recalling. Had I given you all a formula, Karuna, sine C plus sine D or sine A plus sine B. Can you recall, Karuna?
Yes, sir.
Tell me the formula, recall. Open your
2
notes.
sine 2 sine c plus d by 2
2 sine C plus D by 2
into cos c minus d by 2.
into cos C minus D by 2. Okay, okay. Is this applicable here, by the way? We are just trying. Is it applicable here, by the way? No, right?
No.
It isn't? Sure? Okay, what about
Uh,
sine and cos? Did we have any graph formula for sine C and cos D also? Or sine A plus cos B also?
no, sir.
Okay, so now let us write it down in case and let us understand how will we solve such cases. Okay, so class, what do we do in such cases is we write it this way: x is equal to 4. Suppose we have sine pi t, right, plus cos pi t. What do we do is I will multiply divide by root 2. What I'm saying, I'll multiply divide by root 2. Why root 2? I'll tell you in a short while. Then take this root 2 inside. Okay, take this root 2 inside. Now once I have this, I have 4 by root 2, right? And then instead of root 2, what can I write? Cos of, tell me, cos of pi by 4, right, Karuna? So cos pi by 4
Yes.
sine pi t, right? Plus cos of, or instead of this, I can write sine of pi by 4 and cos of pi t, right? Now, does it resemble any formula we have read in the past, Karuna? Sin A cos B plus cos A sin B, right? See here,
Oh, yes, sir.
see here. This is sin A, right? Cos B. Then the same B. First, which was coming with cos, it is now coming with sine. See here, now sine B cos A, right? What expands, for what value is this expansion valid?
Sine A plus B.
So class, write this formula, everyone. There is a formula which we had read in the basics of the chapter and the basics of mathematics, right? And the formula is sine of A plus B. Sine of A plus B is equal to sine A cos B plus cos A sine B. And from there we are coming to this topic, right? From there we are coming to this understanding that when I'm given with the expression of x, I had x is equal to, see here, I'm writing the last step again, 4 by root 2, 4 by root 2, then we wrote, which is equal to sine pi t into cos pi by 4, sine pi t into cos pi by 4 plus sine pi by 4 into cos pi t. So here, try comparing, right? That A is nothing but pi t, see, right? A is nothing but pi t, right? Similarly, we have B is nothing but pi by 4. Have a look, class. B is nothing but pi by 4, right? Same formula. Are you all able to relate this, class? Are you all able to relate to it, right? So let us take uh, Karuna again. Karuna, yeah, tell me what will be the next step.
So x is equal to 4 by root 2 sine pi by 2 plus pi by 4.
Hmm,
Pi t by pi by.
pi t plus pi by 4. Excellent. Super. Super. So now try to tell me, is this formula now very equal to the equation of an SHM that we had read?
Yes, sir.
So we have sine omega t plus phi. Now tell me what is A? Amplitude.
4 by root 2.
Yes. So this was the answer for this question. Are we clear?
Yes, sir.
Now let me come back and tell you why did I take root 2 here? Why did I take root 2 here, right? So class, in order to solve any such kind of question, here is the technique, here is the trick. Whenever you are given with the expression, right, whenever, note it down with you, whenever you have the expression A sine omega t plus B cos omega t, right? You can convert this in the form sine of A plus sine of A plus B format, right? How will you do it? See here. Why did I write root 2? Because we see the coefficients of sine and cos. What was the coefficient of sine here? 1. The coefficient of cos here was again 1. See? So here, what do I do? I take the coefficient of A here and this is the coefficient of B here, right? Now, Mahila, would you like to try along with me? Yes. So you just have to answer me. No worries. I'll keep helping you. Yeah. So what do? We multiply and divide by under root of A square plus B square. See class, what I'm doing? I'm multiplying, dividing by under root of A square, B square, right? Then have a look, class. This is A sine omega t plus B cos omega t, right? Now allow under root of A square plus B square to be here and take the denominator inside, right? So we have it this way. right? Now class, this term, see, this term, a by under root of a square plus b square, or let me write it this, a square, sorry, a by under root of a square plus b square, b by under root of a square plus b square. These terms are actually the sine and cos of the same angle. See how? Sine and cos of the same angle. Let us see how. So let's say I have a triangle here. I'm drawing a triangle, right? Have a look. I have a right angle triangle, okay, for which one of the sides is A and the other side is B. So what will be the hypotenuse look like? What will the hypotenuse look like? The hypotenuse will be under root of A square plus B square, right? So suppose, right, suppose I take here this one as alpha, right? Or let us take this as phi. Let us take this as phi. So Atul, can you tell me what will be the value of sine phi from this triangle? Yes, Atul, sine phi.
Uh, Sine phi is b by under root a square plus b square.
So b by under root plus a square plus b square is sine phi, right? So I can write this as sine phi, correct? And
Yes, sir.
what about cos phi?
A by under root a square plus b square.
Very good. So we have cos phi is a by under root of a square plus b square. So how does our equation transform? Now our equation becomes cos phi sine omega t plus sine phi cos omega t. Correct, Atul?
Yes, sir.
Now what kind of equation do we get? We get an equation.
Sine omega t
Yes,
in the form of sine a plus b,
absolutely correct.
sine omega t plus phi.
Yes, yes, absolutely correct. So class, now we are able to see that we have got this equation which is very equal to or close to the format we just read, right? Sine A cos B plus cos A sine B, which is nothing but sine of A plus B, sine of A plus B. So see what we have done. We have written it down as under root of A square B square sine of omega t plus phi, right? Is equal to the displacement. Are we clear, Atul, on this aspect?
Yes, yes, sir.
Now, class would like to tell you all that you need not do this entire procedure again and again. If I'm asked to find out amplitude, what I can simply do is just see what is the coefficient of sine omega t, what is the coefficient of cos omega t, right? And then take the under root of square of both and sum them. So all I mean to say is something like this. So let's say I'll give one more question. Let's say we have y is equal to this time, right? 2 sine omega t plus 6 cos omega t, right? Now I tell you what should be the amplitude of this SHM. Now try this. Yes, Anukriti, can you try? What will we do? It will be equal to, yes, Anukriti, try it out. Even if you're wrong, no issues. Yes, try.
Root of a square plus b square,
That is under root of 2 square plus 6 square, correct?
6 square
And
by,
we have the formula sine of omega t plus phi, right? Correct?
yes, sir,
And therefore the amplitude is going to be, how much will be the amplitude? Calculate and let me know. 36 plus 4, right?
4
So under
root
root of
50,
40, correct?
root 4, 40.
Right? Excellent,
Yes, sir.
excellent. So this is basically 2 root 10, right?
Yes, sir.
So class, are you all clear? Let us take next question from Samriddhi. Samriddhi, try this. If I have y is equal to 9 cos omega t plus sin omega t. You need to find out what will be the amplitude of this harmonic motion. Yes, try it out. Yes, Samriddhi. Thank you. Thank you, Anupati.
So amplitude.
Yeah,
So amplitude is equals to root of 9 square plus 1 square,
yes.
which is equals to root of 81 plus 1,
Uh-huh. Which is
which
given
is
by
equals
completed.
to root 82.
Very good. Very good. Are you clear with the concept, Samriddhi? Whenever you have a question
Yes,
of
sir.
this sort, will you be able to crack it from now?
Yes, sir.
Sure?
Yes.
Oh,
Sir,
yeah, tell me.
my question is that if there is three terms, then how to find amplitude?
Okay, excellent question. Excellent. Let's say we have, if we have three terms, right? So let's say, first of all, will it be SHM or not? Tell me that.
Yes, sometimes it will be.
Okay, so do one thing. We'll take one such question, but you need to provide me a question of this sort. Then we'll build upon this. So it will actually vary from case to case basis, right? As you're saying. So do one thing. Get me one question, right? And we'll take it up in class according to your doubt. So whatever your doubt is, let's say, make sure that your doubt is concrete and has a question, actual question with you, so that we'll be able to build upon it, and you can also verify, okay, this is the question that sir considered, and the answer I'm able to match, right? Am I clear, Samriddhi?
Okay, sir.
Right? In the next
Uh,
class, just get me one question which is on this basis, and we'll take it up. Or you can send it to me before the class, so that it will be also easy for me to take it up in class itself, right?
okay, sir.
All right, great, great, great. Please do remind me in the coming session and do send me the question, right? Okay. All right. Now, class, now that we have reached this far, we'll have some quick insights into calculation of time periods for different case by case basis, right? So let's take the cases. Suppose you are given with a spring and mass arrangement. Let us say you have a block, right, of mass m, which is connected to a spring of spring constant k. I pulled the block from its natural length. I pulled the block from its natural length, right, and left it. So this block will start doing simple harmonic motion. This block will start doing simple harmonic motion, right? And it will keep oscillating. It will start oscillating between two given points. See here, between two amplitudes, the graph will start, this body will start oscillating, right? So this is how an SHM of a block will take place. And we have already discovered that how do you write the expression for a general SHM. See here, we have f is equal to minus kx, right? From here we had got ma is equal to minus kx. Therefore, a is equal to minus k by mx, and therefore omega square is equal to k by m. Correct? So we had got, this implies omega is equal to, omega is equal to under root of k by m, right? Therefore, we had 2 pi by t is equal to under root k by m, and therefore t is equal to 2 pi under root of m by k, right? Under root of m by k. Class, please take this as a note. Please take this as a note. Now there can be different cases, class. There can be different cases. This SHM can be taking place on an inclined plane also, but still the equation of the SHM will remain same. See here, we can have this mass over here with any angle theta, but still the time period will remain same, 2 pi under root m by k, because it just depends upon mass and the spring constant, not how the mass has been oriented, right? How the spring has been oriented. Upon that, this time period does not depend. So class, whether you have a spring mass arrangement of this sort or horizontal or vertical, in all the three cases, see here, we have different spring mass case, right? So this is spring mass cases. So here we see in each of these cases, the time period is given by 2 pi under root of m by k. 2 pi under root of m by k. Class, please take this note with you. Please take this note. Yes, class. That time period is independent in each three cases of the orientation of the block. It does not depend on how the block has been oriented, right? Class, please take a note of this. So class, based upon this, I am going to send you all a list of formulas, right? A list of formulas. Make sure that you will see those formulas, right? Which will involve some formulas also for the damped simple harmonic oscillators, etc. We'll solve some basic questions on how damped harmonic motion takes place. And I'll give you all some assignment questions based upon this also, right? And then let us continue with the chapter or with the unit oscillations and waves, where we are going to see some concepts in waves very properly, right? And then make sure that if we get any question in wave, we are able to tackle it very nicely, right? So we'll see some theory in waves also, but before that, we'll solve some questions, more questions in SHM, right? Okay. So thank you very much, class, for being a part of this session. Let us catch up today evening once again for the second session, right? Which will be more of a practice session on whatever we have read until now, whatever we have read until now, right? So let us meet today in the evening with some questions, right? I'll send you all some questions, right? Based upon SHM theory, whatever we have read until now, let us solve all of that and start with waves, right? Thank you all. Thank you for being a part of the class. Let us catch up today in the evening or the afternoon time. That's 3:45 to 4:45, right? Thank you. Thank you all. Thanks a lot. I hope this is clear to everyone, right? Thank you. Thank you.